Okay, so hello everyone. Thanks for joining, and special thanks to Robert and Akush for inviting me to present this paper. That's joint work with Berthold Herrendorf, who, by the way, is in the audience and happy to answer questions in the chat. So the paper is about occupation employment and how it is affected by structural transformation. So more specifically, in the paper, we address the question how the composition of occupation employment changes as countries grow richer. And as follow-up questions, we want to understand the main driving forces of the observed patterns, and moreover, whether that tells us something about how we should model labor reallocation in the context of structural transformation. And as you all know, the conventional approach is to measure employment and employment reallocation at the sector level. So given the focus of our paper, two natural questions are, why is it actually interesting and useful to measure employment at the occupation level instead of the sector level? And the second question is, does it actually matter, or does it make a difference whether we measure employment at the occupation or at the sector level? And there are certainly cases where it does not matter. So for example, think of an agricultural or fishery worker. These are occupations that produce goods, especially agricultural goods, and they're mostly employed in the agricultural sector. So in this case, there's a strong link between the sector and the occupation. It does not matter whether we look at sector occupation, at sector employment or occupation employment. However, there are many examples where it matters. Think, for example, of managers. That's also an occupation that produces mostly services, but it's employed not only in the service sector, but managers are employed practically in every sector. Okay, so why is it actually interesting or useful to focus on occupation employment? Now there's plenty of work, plenty of research showing that occupations matter a great deal for important labor market aspects. So for example, human capital. It has been shown that human capital is mostly occupation specific and not sector specific. Occupations also matter for mobility or also for important labor market trends, for example, job polarization. So therefore, an advantage of measuring employment at the occupation level is that we can directly speak to labor-related aspects of structural transformation. For example, we have a companion paper in which we study the effects of occupation-specific barriers on the sectoral reallocation of employment. And another big advantage is that occupation employment is not affected by relabeling that results from outsourcing. And to understand what I mean by this, to fix ideas, think of cleaning services. Now, the in-house cleaning services by a car manufacturer, for example, are counted as industry employment. However, if that service is outsourced and purchased from the market, then it's counted as service employment, even though it's the same activity as before. Okay, so the issue is that the observed increase, say, in service sector employment that we observe in the data may to some extent be due to relabeling that comes from outsourcing. And this issue does not occur when we measure employment at the occupation level, because the cleaner is a service occupation no matter where it's employed. So our contribution in the paper has two parts. First, there's an empirical part in which we establish a set of facts describing the structural transformation of occupation employment within sectors, but also across sectors. Okay, and these facts are, of course, the main motivational evidence for this paper, but they may generally be useful for people working on labor-related questions of structural transformation. And then second, we propose a simple model that allows us to explore the driving forces of the observed employment patterns. And this framework is very simple. It can be extended in a straightforward manner to address generally questions related to structural transformation and occupation employment. Okay, so here's a brief overview of the rest of the talk. So I first show you some evidence, then present the model, then derive some analytical results, then some quantitative results, then we do some experiments, and finally we conclude. Okay, so let's start with the evidence. The evidence comes from the IPAMS database. So this is the collection of census information. So it's really the microdata that we use in order to derive and compute our facts. And it's a very large collection of data. So our sample covers most of world economic activity. So it's 2/3 of world output, so 3/4 of world population. And the big advantage is that we have rich countries and we have poor countries. Okay. So now to get started, we follow the conventional approach, and we compute employment at the sector level, where we distinguish between the three usual broad sectors, namely agriculture, industry, and services. We do this to check whether our sample of countries produces the usual patterns of structural transformation, of sectoral employment. So here's what we find. Every dot in this figure is a country year observation, and the blue dots are observations for the US. In fact, the observations for the US, they go back until 1850. Now, it's reassuring to see that the patterns of sectoral employment that our sample produces is in line with previous findings. So we see that poor countries have a large employment share in agriculture that shrinks as countries get richer and services go up. Okay, that was the first step. Now in the second step, we compute employment at the occupation level of a broad occupation groups. And there we distinguish between three broad occupation groups, namely agricultural occupations. That includes, for example, agricultural workers, fishery, forestry workers. Then we have industry occupation that mainly includes crafts workers, machine operators, assemblers, and that sort of occupations. And the third group is service occupations. That includes managers, clerks, market service workers, etc. Okay, so the basic principle that we apply here when we classify occupations is that goods occupations are those occupations where people produce or process and transform tangible output, and service occupations are those where people produce intangible output. Okay, so at a first glance, this classification into goods and service occupation may look a little unusual, but in fact, there's a close connection between our classification and standard classification schemes, such as the distinction between white-collar, blue-collar workers, brawn and brain-intensive, or routine and non-routine occupations. So here are the figures for occupation employment. And in fact, they look very similar to the ones that we've seen for sector employment. So let's put them on top of each other. And they look very similar, actually almost indistinguishable. And perhaps for agriculture, that's not so surprising because, as we said before, agricultural occupations are almost exclusively employed in the agriculture sector. But for services and industry, it is surprising because service workers, they are employed not only in the service sector, but in fact also in many non-service sectors. And goods producing workers are also employed in the service sector. So for example, the University of Frankfurt employs not only service producing people like me, but they also employ carpenters or plumbers or gardeners, so people that actually produce goods. And
can I answer two clarifying questions from the chat?
Yeah.
First one is whether this is only formal or employment or also includes informal. And the second one, how do you deal with new occupations, and or is this a constant set of categories across the sample?
Okay, so this is only formal work. So the set of occupations that we work with, this is given by IPAMS. So it's not that we categorize occupations from the raw data, but this is already harmonized by IPAMS. They come up with a list of occupational groups. And the good thing is that most of the surveys are recent surveys, where you could think that the set of occupations is comparable across countries, and there's not so much entry and exit over time. So for some countries, the US, we go very far back in time. So we go back until 1850, but for most of the other countries, especially poor countries, we have survey observations only for the recent years. Okay, so to address the point how the occupational employment looks within sector, in order to get a better understanding of the composition of occupational employment within sectors and also how that changes with structural transformation, we compute the employment shares of occupational employment within each sector. And here we collapse the industry and the agricultural sector into the goods producing sector. So before we had 3 sectors, now we work with 2 sectors. The goods sector now comprises of the industry and of the agricultural sector. And quite surprisingly, we find that the employment shares of occupations, they change substantially as countries grow richer. Again, this is also the main finding of the empirical section, namely that in each sector, the employment share of goods occupations shrinks over time, and the employment share of service occupation grows. Okay, this is something you can see in this table. This applies also to the goods producing sector, that over time, as countries grow richer, actually becomes dominated by service jobs. Okay, so for example, in rich countries, more than half of the employment in the goods sector is actually service jobs. Okay, so you see 52% of the employment in the goods sector is employment by service occupations. So, and then we also do a shift share analysis where we ask how much of the total reallocation from goods to service occupations is actually due to within sector reallocation and how much is due to a cross-sector reallocation. And we find that it's almost half of the reallocation that we observe from goods to services is due to within sector reallocation. An important implication is that if you focus only on the sectoral employment shifts, then you would miss half of the actual employment reallocation across sectors. And another important implication of this evidence is that outsourcing and the associated relabeling of jobs is not the main force behind the increase in the service sector, because if it was, then we should see a decrease in the share of service occupations in the goods sector employment, because all the cleaning services are outsourced. Therefore, we should see a decrease in the employment share of service occupations. But we see exactly the opposite. Okay, now in the next step, we propose a simple and also tractable framework that that includes sector and occupation employment. And why do we need a model at this point? Well, we want to have a framework that allows us to identify the driving forces behind the employment shifts that we observe in the data. And also the model is very simple, and we wanted to propose a model that people can use and extend to address questions related to structural transformation and occupational mobility. The model is very simple. It's a modified version of the model in Ney and Pissarides. It has 3 sectors of production. The sectors produce investment, goods, and consumption goods and consumption services. And the investment sector has an AK technology, so all the labor allocation or all the labor reallocation happens between the 2 consumption sectors. Then we introduce 2 types of labor, namely goods occupations and service occupations. And we say that production in each of the consumption sectors is Cobb-Douglas. So it's with capital and with labor. And labor here is not raw labor, but it's a composite. It's a composite of both types of occupations. So the N here is the occupational labor input into the production of output. So for example, NGS is the amount of service occupations that are employed in the goods sector. So the capital letter in the subscript denotes the sector, and the lowercase letter denotes the occupation. So goods occupations can be employed in both sectors, namely the goods sector and also in the service sector, and the same for service occupations. We don't introduce sector TFP, that's very important to notice, but instead we introduce occupation-specific technological progress. Okay, so technological progress is occupation-specific. So AG here applies to goods occupations, and it's the same across sectors. So AG here is the same as the AG here in the service sector, but it's potentially different from the technological progress that applies to service occupations. And we have an elasticity of substitution, sigma, that tells us the substitutability between both types of occupations. And the household has log utility and likes to consume a composite service that consists of consumption goods and consumption services. And again, there's an elasticity of substitution that gives us the substitutability between the 2 inputs. Then importantly, labor and capital, they are perfectly mobile. Okay, so labor can be shifted across occupations and also across sectors, which means that in equilibrium, we're going to have one equilibrium wage. Perhaps that's a little bit of a caveat of our analysis, because in the real world, we observe large differentials in wages across sectors and also across occupations, and our model is not, will not be able to capture this because we allow for perfect factor mobility. We do that because the data that we have from IPAMS does have only very limited information about wages at the occupation at the sector level, so therefore we abstract from that. Then the model is very tractable, it's very simple, so therefore we can derive analytical results. And one important result is summarized by this proposition here, which says that in fact we only need a very small set of restrictions on the parameters so that the model is qualitatively or can qualitatively match important observations about structural transformation. So what we require is that both types of occupations are complements in the production function. So sigma is between 0 and 1. Goods and services have to be complements in the utility function. There's a lot of support in the data that usually says that epsilon, the substitutability, is actually close to 0. We need that the goods sector employs more goods occupations than the service sector. And importantly, we need that technological change is faster for goods occupations than for service occupations. If these restrictions are met, then the equilibrium growth path that we get is consistent with the employment reallocation within sectors and across sectors that we observe. So the reallocation of employment, the reallocation between occupations within each sector, but also across sectors. It's also consistent with the increase in the relative price of services. It can also match faster labor productivity growth in the goods sector, which is also a feature of the data, and the reallocation of expenditures and employment toward services. To develop some intuition for this proposition, let me present, let me make a few comments about how the model works. So the equilibrium conditions give rise to an expression that says that the employment of service occupations relative to goods occupations in every sector depend on the relative technological change between both types of occupations. So when goods occupations experience faster technological progress than service occupations, and both occupations are complements, so sigma is between 0 and 1, then this expression tells us that labor is reallocated from goods to service occupations in each sector. Okay, then at the same time, since the goods sector uses goods occupations more intensively and goods occupations experience faster technological progress, this leads to labor productivity growth being faster in the goods producing sector. And due to the standard inverse relationship between labor productivity and relative prices, this leads to an increase in the relative price of services. When the relative price of services goes up, and epsilon, the substitutability between goods and services between 0 and 1, this leads then to a reallocation of resources, namely of employment and of expenditure from the goods sector to the service sector, something that we observe in the data. And notice one important thing: in order to make the model qualitatively consistent with these facts, we only need uneven occupation-specific technological progress. We don't need uneven sector TFP. So in the interest of time, let me skip examples why goods occupation bias technological change is actually something that is empirically relevant. Let's move on to the quantitative analysis. The purpose of the quantitative analysis is to see how far the model can go quantitatively in order to match the observed structural transformation. We calibrate the model, the parameters, to match employment targets for the US for 1950 and 2000. I'm not going to show you all the parameters, but only those that are important, namely that the data supports the substitutability between both types of occupations, which in fact is smaller than 0, and also a faster technological progress for goods occupations. And this is just to say that the calibrated model can match the calibration targets very well, but also it fits the non-targeted statistics like sectoral prices, labor productivities, and expenditures very well. And again, this the only input or the only driver for that, or the only driver that's required to match this, is uneven occupation technological change. And then the last thing I want to say is that to demonstrate the usefulness of the model, we run 2 experiments. In the first experiment, we take the calibrated model, we feed in technological change, and we ask how well the model can match the period, or the US, in the period before the 1950s. Okay, the data for the US starts in 1850, and we can ask how well does the calibrated model match the US, the period before 1950. We feed in the technological progress that we've calibrated post 1950, and then we get we get model predictions for 4 employment shares, which are for 2 occupations in 2 sectors. And that's the red line. The blue line, or the blue dots are again the data. The grayish diamonds are the calibration targets. So all the data points that come before the calibration targets, they were not used in the calibration. And you see that the model actually produces a very good fit for the occupational employment for the US. And since the US, in fact, is an average of the world, or at least of the sample that we have, that we work with, it's also a very good representation of the world average. Then in the second experiment, and that's the last thing I want to say, we become a little adventurous and we use the model for forecasting, namely forecasting occupational employment. We do this because the BLS also does that. The Bureau of Labor Statistics produces occupational employment forecasts. They publish that in the Occupational Outlook Handbook. And it seems that it's a very important statistic. So at least they claim that these statistics are among the most downloaded statistics of the BLS. I guess policymakers are interested in that, perhaps teachers, parents, I don't know. So what we do is we take our model, we calibrate it for the sub-periods that correspond to the periods that the BLS does their predictions, and we do out-of-sample predictions. And then we compare our forecasts with the data and with the BLS forecasts. Okay, so here, I mean, the model produces a lot of forecasts. I show you only those with respect to the employment share of goods occupations for different sub-periods. And in the data, we see that goods occupations go down over time. That's what we've seen in the first slide. So here we have the actual change in employment share. Then we have the 2 forecasts, our forecast and the BLS forecast. And whoever gets the blue label wins or is closer to the data. And you see that our simple model actually outperforms the BLS forecasts in most of the cases. So I'm out of time, so let me conclude. In the paper, we present a set of stylized facts about occupational employment and how it changes as countries grow richer. And an important takeaway is that there's a large reallocation of occupational employment, not only between sectors, but also within sectors. So given the large reallocation within sectors, we would actually miss half of the actual reallocation between occupations if we focused only on sectoral employment shifts. And we also find that outsourcing of service occupations cannot be the main driver of the increase in service employment. So relabeling may occur, but this is not a big issue. And then we propose a trackable framework of structural transformation that has sectors and occupations, and that emphasizes the role of occupation-specific technological change. So it's consistent with a lot of patterns that we see in the data related to structural transformation. And it's a simple framework, but as I said, it can be easily extended and applied to study labor-related questions of structural transformation. Okay, so it's all I wanted to say. Thanks a lot for attention, and I look forward to the discussion.
Thank you so much, Georg. Another great presentation. Let's open the floor. Either raise your hand or put a question in the chat. I see a first one by Hagen Kruse. You would ask your question.
Yeah, thank you very much, Robert. So my question was, why do you focus so much on only 2 different sectors? Is it driven by the model or by data availability? Because it would be interesting to split service and manufacturing occupations into 2 or 3 groups, right? Into a low skill and high skill occupations.
Okay. Do you want me to answer now, or shall I collect?
Well, let's collect some questions.
Okay.
Yeah, I see Francisco.
Okay.
Yeah, you're still on mute. Still can't hear you. We still can't hear you, Francisco.
Okay.
So next one. Who else? Heidsen?
Yes, so most likely this is related to the question that Hagen raised. Thanks for this interesting presentation, Georg. My question is, and how should I interpret what you call occupational technological change? So we know about sector specific technological change, but what do you have in mind if you talk about occupational technological change? Is this like the type of technological change that Acemoglu and Autor in their handbook paper in 2011 had in mind, or is it something else? So I'd like to hear your thoughts on that.
Francisco, ready for round two?
Hello, do you hear me now?
Yes.
Yeah.
Perfect. Now, if I understand correctly, you identified, you could have both sectoral productivity growth, differential, or occupational. You guys focus on, if I understand correctly, on occupational. Is there a way to distinguish the two or distinguish the relative importance of the two?
Okay. Further, Luis?
Hey, how are you? So, quick question. So I noticed you didn't acknowledge the structural transformation within investment. But my question is this just to close the model, or do you see any evidence that this is not a first order condition when we talk about occupations versus as we used to talk about the sectors? That's it.
Julieta?
Hi, yeah, very interesting paper. So I had a question on aggregation that is related to, I think, the first question that you got, and also to Paco's question. If I were to run a horse race where I have the occupational component and the sectoral component, then potentially the level of aggregation of occupations that you use may matter for this. So that's something that I wanted to ask if you guys have explored. And then thinking about what this occupation-specific technical change looks like, how do you, or is there a mapping to the standard bias technological change that we have seen, typically skill bias and phenomena like capital embodied technology, et cetera. So I just want to know if you guys have thought about those links.
Okay.
Okay, a lot of questions. So
Go ahead.
embodied. Okay. So let me start with the first one. Why do we consider only 2 sectors and 2 occupations? So in order to make use of the full data set, namely, I think it comprises of more than 180 surveys, we can only use 2, at most 3 sectors or occupations, because for this very large sample of countries, the IPAMs provide a consistent coding of occupations. If instead we wanted to limit analysis to a restricted sample of countries, say between 20 or 30, I forgot the exact number, then we could also rely on a harmonized 3-digit occupational and sectoral classification. So this is a little bit of a trade-off. Do we want to have more countries, or do we want to have more occupations? If we wanted to know more or learn more about the dynamics within sectors or between occupations, then of course it would be useful to rely on a smaller set of countries for which we have the occupations and the sector at a higher level, at a lower level of aggregation. Okay, so it's a little bit of a trade-off. And the question: how do we interpret occupational technological change? And what are examples? So I didn't have time to talk about this, but the empirical literature has identified or has suggested that there are several types of technological change that are more likely to be occupation specific than sector specific. So for example, Golden and Katz, they have a paper where they argue that, for example, 19th century manufacturing technologies, they replaced mostly artisans and craftsmen. So this is clearly something that we have in mind, and also in the model, namely that clearly corresponds to occupation-specific technological change. Or when you think of Baumol's idea that there's very little technological progress in the production of labor-intensive services, then this is probably also something that is related, or that is linked mostly to service occupations. And then lastly, Autor and Dorn's idea, or Acemoglu and Autor's idea about routine bias technological change, that's, I would say, is also an example for a source of technological change that is good specific. Then about the question about distinguishing between sector and occupation technological change. So if we only had sector technological change, then we would be back in the standard Ney-Pissarides model, and then we could match, or the model could match basically all the facts, at least qualitatively except for the within sector reallocation of employment. If you don't have a source that works within the sector, and occupation-specific technological change is such a source, then you cannot match the employment reallocation within sector. To distinguish the two, we would need additional information from the data. Wages could help, because if you observe wages at the occupation at the sector level, then this would be information that could be used in order to disentangle the sector TFP and the occupational component of technological change. Then the question about structural transformation in investment. Of course, there is important work, and some contributors in the audience that have looked at structural transformation in investment, and it's clearly important. And we didn't include it because we wanted to keep the tractability of the model, but clearly this is something that can be addressed and perhaps should be addressed, because the consumption sector is the consumption producing sector is not the only sector where structural transformation goes on. Then the level of whether the level of aggregation matters for the results. Well, the short question is I don't know, because we haven't tried. We could go to a different level of aggregation and see whether that actually matters. So the simple and honest answer is I don't know. The last question about whether there's a mapping between our notion of occupation bias technological change and skill bias technological change, or capital embodied technological change, that was also already raised before. And as I said, there are examples of sources of technological change that people have come up with, where it could be argued that it's occupation biased rather than sector biased. So routine biased technological change and skill biased technological changes.
Joe, I see you had a remark in the chat about non-homotheticity. Do you want to say a bit more about that, or?
Can I also just follow up with
Sure.
them? I think I misunderstood given Georg's answer on wages. I misunderstood. So I had a question on the chat as of whether the movements in earnings that you see for occupation sector workers and the movement of employment that you see are consistent with the complementarity that you need to assume between occupations. I think the answer in the chat was yes, we see this, but you seem to suggest that you guys don't have enough wage data. Did I misunderstood this?
No, you understood correctly. So the IPAMS international, the census information that is provided there has very limited information about
that's
wages.
what I thought.
So, I mean, for some countries there is information, but at least at this point we didn't dig deeper in order to use this information. But that's certainly an important component, especially when it comes to labor relocation, namely what's how do wages look like?
Robert, I didn't realize that you were asking me to elaborate. I thought you were asking Georg to just respond. Mine was just a point that, like, for matching output, value added, the non-homotheicities are important. And I guess maybe it's because you've combined agriculture into goods, and it's particularly important in agriculture. But it's interesting that the non-homotheicities don't seem to play a role at all when you're trying to match the patterns for labor. I mean, for occupation.
Yeah. I mean, as you said, if we had three sectors and we wanted to match the hump shaped in manufacturing, employment and occupations, then perhaps a more sophisticated preference structure would be required.
So maybe briefly on the you mentioned wages are a big issue. I mean, it has been this ILO survey and I know people like Freeman and Remco Oostendorp have done work on putting some of that together in a accessible format. So that could be a relevant addition to this data work you've already done.
Yeah, very good. Mm-hmm.
All right, thank you all for this discussion as well.